In this section, we're going to take a look at what a true battery is, and I want to look at what the name of battery is. And I'm looking online and reading this. So I want to read what a battery is in terms of military. Batteries were divided into sections of 2 guns apiece, each section normally under the command of a lieutenant. The full battery was typically commanded by a captain. Often, particularly as the war progressed, individual batteries were grouped into battalions under a major or colonel. In military organizations, an artillery battery is a unit of artillery mortars, rocket artillery, multiple rocket launchers, surface-to-surface missiles, ballistic missiles, cruise missiles, etc. So what is a battery? Well, a true battery is actually multiples. Battery means multiples. So a true battery is a group of voltaic cells. So if you have one voltaic cell, like we have right here in a previous lecture, this is not really a battery because it's just one voltaic cell. If you have multiples of these, then you have a true battery. Well, taking a look at section 21.3, we were looking at batteries. Well, these are called batteries, but they're not truly batteries. Your A batteries, your AA, your AAA, your C batteries, your D batteries, they are not true batteries. The 9-volt battery, however, the square one, actually is considered to be a battery because if you bust one of those open, you'll find that there are actually multiple little batteries on the insides of those. So there's multiple voltaic cells inside that rectangular, squarish 9-volt battery. So a true battery is a group of voltaic cells. So we're going to be looking at your car and how your car actually recharges the battery. So we're going to be starting off with what looks like a voltaic cell, but if you remember that these are happening actually in multiple voltaic cells. So we have our anode, which is over here. We're always going to draw our anode over here. And we're going to have on the other side, we're going to have your cathode. So here's your positive side over here. And we have these plates. You'll read about these when you're doing your homework assignment. And these plates are sitting in a solution or liquid. And this is your battery acid. Okay, so I'm going to put acid here and acid here. So we are going to try to start the vehicle. And when you do so, you're going to be clicking on the ignition. So here's our goal. And our goal is to start the car. But the goal is also going to be to keep the car going so that we don't run out of our battery. So inside the acids here, there are some ions. And inside here are also some ions with the acid. Okay, so we've got these positive ions here, and we have these positive ions that are over here as well. So we are trying to get our car started, and in order to do so, we have to ignite our gasoline. And that takes place inside your cylinders. Okay, so here's your cylinder here. Okay. Depending upon what type of vehicle, you have a different number of cylinders. The more cylinders that you have, the more powerful, the stronger it's going to be. And what we have is attached to this cylinder is going to be a spark plug. Okay, so the spark plug has this shape this, and it attaches to a cap. So it's a strong electrical connection, but we're just going to leave it like this. And it has, at the very, very end, if you've ever seen a spark plug before, there is like this little curly Q and this other piece of metal that sticks out as well. This is where the electrons are going to jump and build up, much like Benjamin Franklin saw the sparking or the arcing of the electrical current. So this is going to be the source of the electrons, and instead of just passing them from here to here, we have to pass them through the voltage meter or through the light bulb or through some type of device. So we're going to have the electrons that are leaving the anode. They're then going to go to the spark plug, because we need to generate a spark plug, or the spark from the spark plug, to ignite the gasoline. So the electrons come into the spark plug and they supply the spark. And inside your cylinder, it's like a syringe, you have this piston that has the capacity to move up and down. So the spark plug is just sitting there, and inside is gasoline. So we have a small bit of gasoline, and with this gasoline comes the spark. The spark's going to ignite the gasoline. What happens to gasoline when you have a spark? You have an explosion. That explosion then is going to expand the gases on the inside of the cylinder, and it's then going to push this cylinder down. I'm just going to push this piston down. So here's the cylinder, here's the piston, here's the spark plug, and the piston is going to move down. Now, this piston is connected to this round device, which when it hits the bottom, it's then going to move back up again. So as it moves back up, what's going to happen is it's going to spit out all of the exhaust, because we've just burned a fuel. This gasoline has lots of carbons in it, and what's going to come out is going to be lots of carbon dioxide exhaust. So the piston has this motion. It was forced down. It has some energy left in it, and it's moving back up again, and then actually goes back down again. And as it comes back down, it draws in or sucks in oxygen. This oxygen is coming from the air, from the outside. This air actually is going to be coming through your air filter, so you have to make sure that your air filter is clean. If your air filter is dirty, it's going to get blocked. It's going to block the air from coming in, and it's not going to allow you to have efficient sparking, because with this gasoline, we need to have oxygen. Okay, it's like the candle. We have a candle to be burned, but we just need some oxygen. But if you have a dirty air filter, it's going to block the oxygen, and the gasoline's not going to be able to combust when the spark comes in. So again, the electron comes in, it sparks, so it actually builds up and it jumps across, and in the process of jumping across, it creates that spark. This spark ignites the gasoline, causes the piston to move down, and then this moves back up. It then pushes out the exhaust. It then comes down for a return trip where it fills in with oxygen. It sucks in the oxygen, and then as it's coming back in, we have an oxygen and gasoline and a spark. We have the perfect conditions for another explosion, which then sets it off for a repeat. So let's follow the path of the electron. This electron just built up and jumped across. It just did its job of sparking the gasoline and igniting the gasoline. And it's going to come over here, and then it's going to then enter into the cathode on the other side. So what's going to happen is, as this bar produces the electrons, just like the zinc, it's going to dissolve, and it's going to become ions. Okay, so it dissolves. So my anode is going to be dissolving, just like the zinc was dissolving. And as the electron comes back for the return into this bar, it's going to meet up with the positive ions. These positive ions are going to be drawn and attracted towards the electrons, and it's going to start to build up deposits. So this is not a good scenario, because if you just continuously, not just when you start your car provides the sparks, but now we have a continuous supply from your battery. Your battery needs to supply continuous sparks to the spark plug so that you can continue to ignite your gas, so that you can continue to go. So over time, you can imagine what's going to happen to your electrode over here. It's going to dissolve. It's going to disappear. What's going to happen over here is you're going to get these deposits, and these deposits are going to build up. So over here, the anode is going to disappear. On the other side, your cathode gets build-up deposits. This is not good for your battery, because we're covering this up with the deposits and we're losing this. So we need to find a way to get our electrons back here to recharge your battery. And that's what your car actually does. It recharges its own battery. So if your battery is very, very low, by turning it on, you can actually recharge the battery by driving at a small distance. Because what's going to happen is this piston is connected to your drive belt, and this will power your vehicles. Or this piston, I don't know much about the engines of a car. This piston is going to, the motion of this is going to create the motion to drive your vehicle. Okay, so what's going to happen is there are also other belts that this is attached to. So we have what are called these turning belts. If anybody knows more about cars, please correct me. So we've got these belts. Some of them are connected to a fan. This fan is then going to be blowing air across your engine to cool it down so it doesn't heat up too much. These turning belts are also attached to your air conditioner. These turning belts are also attached to this other device called an alternator. So an alternator is a very important device in your car, and what it really is it's a generator. What does a generator do? If you can imagine, if you lived maybe in the Gulf Coast area where you get lots of hurricanes or you get lots of power outages, and you need to have a backup power supply. So a lot of people will have the generators. What do they fill the generator with? They fill the generator with gasoline. So the gasoline generator, when you start up the gasoline generator, it's going to have some type of battery in it, which is going to be producing the spark. It's then going to ignite the gasoline. It's then going to turn these belts. Those belts are going to actually create electricity. That's what a generator does. So your alternator is a very miniature generator. And what this is going to do is it's going to burn the gasoline, turn these belts, and it's going to supply power to create electricity. So in a generator, it creates electricity. In your alternator, what it's going to do is the alternator produces electricity or power. And it produces electricity to reverse this process. And it's going to push the electron back to the anode. So if you remember, we were talking about the activity chart. I'd like you to draw the activity, or no, we're going to draw the whole activity chart, but over here, if you remember, we likened the activity chart to the elements that were on a hill. Okay, here you had your zinc up here. Here you had your copper down here. Okay, so I'm going to kind of refer to that zinc and copper. Here is your anode over here. And it's the source of the electrons, so it's the negative. And here is like the copper over here. This is going to be your cathode over here. So just like the zinc throwing the electrons down to the copper, we talked about how you can't have copper being the thing that's being oxidized. You can't have the copper giving the electrons to the zinc. So if you remember, the ball, it really just rolls down this one hill, and this ball is actually the electron. The electron's being passed downhill. Well, what we want to do is we want to take this ball and roll it back up the hill again. We want to get it back to the anode. So our goal, I'm going to be drawing this in a different color now. Our goal is to return the electron back to the anode. Why do we want to do that? We want to do this because, well, if you continuously dissolve this by only having a one-way direction, well, what's going to eventually happen to a battery that's in your flashlight? It's going to go dead. Why? Because what's happened is either that we've dissolved our anode, or we've built up too many deposits on our cathode inside of our little battery. We've run out of this. We've run out of balls to throw to the catcher. It just can't do it anymore. So what do we want to do? We want to return the balls back to the catcher. We want to return the electrons back to the anode. So we do that when the piston is moving, it's attached to these belts. These belts are attached to an alternator, which is really just a generator. This actually has the ability, it has magnets on the inside of it, and as the belts turn, the magnets turn, and these magnets actually push electrons back. So we're going to be pushing these electrons back to the anode. So let's draw an arrow over here. Okay, so the alternator is supplying the power, produces the electricity to push the electron back to the anode. So we're going to take this electron, and well, what's going to happen is these deposits that were previously formed are going to begin to break down. Okay, so we're going to then break down the deposits. So previously the deposits were being built up, but now these deposits are going to get broken down. And from this, we're going to get the electron that's going to get passed back over here. Well, what's going to happen when this electron gets back over here and comes into this plate is the positive ions will say, oh, I want to attach onto you now. Well, what's going to happen to these deposits? They're going to be producing the electron, and the deposits are going to dissolve. That's going to free up and clean up our plate over here. As the electron travels over here, previously what happened is this was disappearing because it was dissolving. It was dissolving and disappearing. Now, with the influx of the electrons, the ions are going to jump onto, the positive ions will jump onto the electrons, and it's going to create more of the anode. So here's the process. Our goal was to return the electron back to the anode. Why? Well, what's going to happen in this process is the cathode is going to become the new anode. So right here, this is going to be pushing the electron back. Okay, so the cathode is the new source of electrons. All these deposits that we form are going to break down. So the deposits break down. And in so dissolving, so these guys are going to become the ions again. So they break down and dissolve. So we'll say they redissolve because they were previously ions, they formed these deposits, they're going to redissolve. Okay, so the electron is sent back to the original anode. The electron is sent back to the original anode. And what's it going to do? When it gets here, the positive ions will be attracted to it. It's going to build it back up again. So the electron's sent back to the original anode, and it builds it back up again. It rebuilds deposits on the anode. So what does this whole process do? This whole process recharges the battery. So as a quick summary, we're going to walk through this all over again. You start your car, and what you're doing is you're connecting a circuit which is going to send electrons from the battery to the spark plug. The spark plug is going to build up with the electrons. Those are going to jump across, but as they jump across, they're going to spark, they're going to ignite the gasoline. The piston is going to then move down, up and down to power these turning belts, which is attached to an alternator. And before this, though, the electron is going to return to the battery, and it is going to draw the ions from the acid, and it's going to create these deposits. We can't have this continuously go on forever because your anode is going to run out of material. The mass is going to decrease. So the piston's attached to an alternator. The alternator has these magnets. These magnets push the electron back. It creates electricity or power to push these electrons back. As it pushes the electrons back, this cathode is the new source of the electrons. The deposits break down and redissolve, cleans this area up. It sends the electron back to the anode, and as it comes back, the ions that are in the acid are going to jump and be attracted to it. It rebuilds the deposits over here, so it's going to increase the mass over here, and it's going to reset your battery to the original starting position. Now, eventually, your car battery will become dead because this process can't continue forever, because you're going to be, as you send electrons back, you will be eroding some of this, and you will not be able to build this back perfectly. So your deposits may actually affect the future functioning of your battery.